All right, this is the key for the throwback assignment for week 3. So first thing I'm going to do in this assignment is talk about what each of these things mean. So the element name there you can see is just like the whole outwritten name of the element. The symbol is that thing that's shown on the periodic table. So it's usually 1 or 2 letters. There's only 1 capital letter in each symbol. The atomic number, and this is important, each individual element has its own atomic number, is the same as its number of protons. So if you're ever wondering what the atomic number is and you have the number of protons, it's the same number. Okay, atomic mass, this is the number of protons plus the number of neutrons. Okay, because protons and neutrons are the only thing in an atom that has substantial mass. An electron is approximately 1/1800th the mass of a proton or a neutron. So the electrons basically don't matter in terms of the mass. So mass is protons and neutrons together. Number of protons is pretty self-explanatory, but is going to be the same as the atomic number if you have the atomic number. So same as atomic number. And actually, this is true in this case for both the protons and the electrons, because we're going to assume that these are all not charged particles, meaning they're neutral. So if they're neutral particles, they're going to have the same number of protons and electrons, which actually means the 3rd column, the 5th column, and the 6th column should all be exactly the same, all right? Because the atomic number is the same as the number of protons, and I'm saying it's not charged, so the number of protons is going to equal the number of electrons as well. Number of neutrons here, generally speaking, the way that you get this, if you don't have it, is you take the mass number, or the atomic mass, and you subtract the number of protons, okay? Because remember, protons and neutrons give you the atomic mass, so if you're looking for neutrons, you take the mass number minus the number of protons. Okay, and then the standard notation, we just have the chemical symbol, and then there are 2 numbers written off there to the left. The top number is the atomic mass. The bottom number is the atomic number, or the number of protons. So in this case, I'm just going to start going through it. Number of protons is got an atomic number of 2, so that's 2 protons and also 2 electrons. To figure out the number of neutrons here, we look at the atomic mass. The atomic mass is 4, which means if you take the protons and the neutrons together, you have a total of 4. Okay, there are 2 protons, which means there are also 2 neutrons, because 2 and 2 gives you 4. On to oxygen here. Oxygen, if you look it up on the periodic table, you'll see that it's atomic number 8. You could also get that because it's the same as the number of protons, which is already listed. The number of electrons is the same as the number of protons, because I said all of these are going to be non-charged particles, so same number of protons and electrons. This has an atomic mass of 16. Given that it has 8 protons, that means it needs 8 neutrons to make up that missing mass there. Sodium, if you look it up on the periodic table, it's got a symbol of Na for sodium. Is atomic number 11, which means it has 11 protons and 11 electrons, assuming that it's not charged. The number of neutrons here, we look at the atomic mass, it's 23. So since there are 23 for the total mass, and then we've got 11 protons, that means we're going to have 12 for a number of neutrons, because 12 and 11 together give you 23. And if we write this out, Na is the symbol. Okay, the thing that goes on the bottom is the atomic number, or the number of protons, that's 11. The thing that goes on the top is the mass, so that's 23. Continuing on here with chlorine. Chlorine is Cl. Its atomic number 17, which means it has 17 protons and 17 electrons. For neutrons, again, we're looking at the atomic mass. We're subtracting the number of protons. 35 minus 17 is 18. Okay, and then when we write this out, the symbol is Cl. The atomic number is 17. The mass is 35. Going here, Li is lithium. Its atomic number 3. That means it has 3 protons and 3 electrons. Neutrons is already done for you, but you can double check here that neutrons and protons gives you 7, which is the atomic mass. So neutrons and protons should go together to give you that atomic mass. So that's just a good double check. So we're talking about lithium here. That's Li. The atomic number is 3. In this case, the mass is 7. C is carbon. If you look up the atomic number for carbon, it's atomic number 6. Has 6 protons. It says here it also has 6 neutrons. So this is the first time where we're going to get the mass, and we get it by adding the number of protons and neutrons together. So that's 12. Okay. If it has 6 protons, it also has 6 electrons because it's not a charged particle. And then writing this out, chemical symbol is C. The atomic number is 6. The mass is 12. Okay, going on here for sulfur. Sulfur has symbol S. The atomic number is 16. All right, this says it has a mass of 32, so that will help us with neutrons in a second. It's got 16 protons, okay? And if it's got 16 protons and the mass is 32, then it has to have 16 neutrons to make up the remaining mass. So what we have here is sulfur. It has an atomic number of 16 and a mass of 32. Si is silicon, S-I-L-C-O-N, silicon. So silicon, you can see there has an atomic number 14. That means that it has 14 protons and 14 electrons. To get the mass here, we're going to go back and look at number of neutrons plus number of protons. That's 14 plus 14. So that's 28. Okay, and then here writing the symbol at the end, that's Si. It has an atomic number of 14. It has a mass of 28. Continuing on here with argon. Argon, if you look it up on the periodic table, it's Ar. It's atomic number 18, which means it has 18 protons and 18 electrons. Okay, to try and find here the number of neutrons, we have to take the mass and subtract the protons. So 40 minus 18, what we get there is 22. So 22 neutrons to make up the remaining mass that we need there. This is argon, so it's Ar. And then the atomic number is 18. The mass number is 40. Silver is Ag. That's atomic number 47. It has 47 protons, 47 electrons. Then we go on to calculating the neutrons again. So we have to take that total mass, 108, minus the number of protons, 108 minus 47, and we get 61. For the number of neutrons there, the symbol here, Ag, it's 108 for the mass, and 47 is the atomic number. Uranium, here it says it's number 92. It's got a mass of 238. So that means it has 92 protons, 92 electrons. Then for the number of neutrons, we take 238 minus 92 minus the number of protons, and we get 146 neutrons. Okay, which means here we're dealing with uranium, mass of 92, atomic number 92, mass of 238. Okay, that is that. I know I went through it pretty quick, so if you didn't understand, maybe just try and think it through, try and do it again. There's lots of materials online you can find if you want to do more practice with this, or come talk to me.